All right, welcome to another Ask a Dev Unreal Engine live tutorial / game dev tutorial. Today is going to be a little bit different, but before we get into what we're doing today, what's up y'all? My name's Kevin. Thanks to a ton of our usual suspects and supporters, Bart, PVM, or Specta, Rusty, great to see you. Arthritic, welcome to the channel. Good to have you all here. I want to give just a quick shout out. Probably should mention my name's Kevin. We try to do these every week, but there are some changes that are coming to the channel. We're going to be pivoting a little bit and focusing more on game dev. That's a future conversation. But today we're going to be talking about relational databases and databases in general. The goal here is to eventually get to a point where I can show you all how to access databases from within Unreal Engine. But before we do that, we kind of have to talk about what a database is and specifically what a relational database is, because we have a lot of new community members who are completely new to game dev. They're artists. They've never done this before. They've come from a completely different career in construction. So today we're going to be talking about and building a small relational database to house all of our saved data. That's what we're doing today. Excuse me, but before we do that, we are going to be let me take a quick second and give a quick shout out to everybody else helping support the channel. So Goldman Vision is our newest Patreon member. Thank you very much for your support. It's kind of what makes the channel even possible. Everybody who's helping out in Discord, they're just crushing it all the time. Our Discord community is alive and awesome. Super helpful, no question too big, no question too small. With this, Default Cube, welcome. With this, let's talk a little bit, before we actually get into building a database, let's talk a little bit about what a database is and why you should and should not listen to me. So, in one of my future lives, I was actually a database engineer, and I built some pretty crazy databases. So just as examples, I built the personnel database for SRA. I built the financial database for Norwest Financial back in the 90s. That's tracking all of the financial transactions at an $80 billion company. But the most fun ones that I built were the incident and injury tracking database for NASCAR. So I spent a bunch of time following around the NASCAR circuit, hopping in and out of Bobby Labonte and Jeff Gordon's cars and installing these little back boxes that helped us track soft tissue injuries. I built that database. It was a lot of fun. And then also more recently, some database for some crazy medical instrumentation that is literally like black magic, as well as countless websites and things like that. So I built a ton of databases. That said, I have spent the last couple decades trying to forget all of that as much as possible because I just want to make really cool video games. Hopefully I can give you all an accessible understanding of what a database is, why it's cool, why it's powerful, but mostly an appreciation for what our software, database, and persistent engineers are doing in the game dev world and why they are magicians. So we're actually going to build a database today. We're going to be working in an abstract way, but first let's talk about an accessible understanding about what a database is. There are lots of different kinds of databases out there. You're going to hear all kinds of terms. There's relational databases, there's NoSQL databases, there's relationship-less databases, there's different softwares that support it, etc. Who cares about all that? Basic understanding. All a database is, in a simple form, not the only form, a simple form, is a bunch of tables that store data. That's it. So what we're going to be doing today is we're going to be building a bunch of tables that store data. And the reason we're doing this is from a game dev. How does this apply to game dev? Lots of different ways, but in this particular case, the one that we're specifically looking at is for our save game. And we have choices how we save our game. We've already been talking about JSON files. One could argue that a JSON file could be considered a kind of database. We've got the save game objects. But then we have this idea of what do we do if we have a live game or a server-based game where our players can play the game on one computer and then go to a different country and they want to use their account, for example. Where do you store that information? Generally speaking, that is not stored locally. That is stored on a server somewhere, usually in a database. Now, the format of the database, everything like that, is going to be dependent upon the game, etc. But let's talk about this. So, if you have players that you either want to be able to travel around and get access to their accounts, and there may be portions of your data that is stored, like the count information, progression maybe, I don't know, but that's one thing. So we're going to keep our database on a server. That's one option. Another option is you have an RTS that's played locally, for example. An RTS has a lot of data. It's the state of all of the houses and the buildings and the enemies and everything that's going on. You might create a local database. Now, that's something like on a switch, for example, right? You don't need to store it in the cloud, but you still use a local database because, as you'll see in the end today, having it in a database makes all the information accessible, editable, and super discoverable, which is really cool. So we've got local databases, we've got server-based databases, there's different programs that store them. It doesn't matter. At the core, it's all a bunch of tables, and it stores our information. So what are we actually going to do? Let's take a look at building this out. And I think if we build this out step by step, you all will start to understand. So let me spell out what we're working with here. We're going to be working with a local database in this particular case. There's no reason for me to set up a whole server to demo this because all of these principles will apply whether it's local or server or etc. Okay? Brain grapes. Yeah, we can do a Q&A stream. Welcome to the stream. Taha. Oh, Taha, that's great to hear. ER diagrams, here we come. Yep, Warren is all over this. Okay, we are going to be talking about ER diagrams as well. I'm going to show you what this stuff. Don't worry about it. All right, so this particular cool tool, this is called dbeaver. This is a tool that you can download for free. It's basically a database visualizer editor tool, and it's going to allow us to demonstrate what we're doing today. The biggest thing to understand here is I've created a new database up here on the left. It is called GameSave Live. And what we are going to do is we're going to build out this database. And rather than talking about it, let's just get going. And I want you all to put on your database development hats and start thinking. Think about saving player data. What is something that we need to know, or what, like we're going to build our first table. What might our first table be? What do we need to store in regards to a player that we can build our first table called table player? So what I'm going to do is I'm going to right click, and while I create this new table, I'm going to name this table table player. You all type in, let me know what you think we should save regarding our player. Okay, we're just building a table, y'all. This is nothing crazy. Okay, player's location, that's a good one. We're going to get to that. Hunter51, welcome to the stream. But how about even more basic than that? How about a player name? Right? Let's go name. So all I'm doing is inserting fields in this table. So we're going to go name here, and I'm going to call this, this is going to be text. So when you insert a field into a table in a database, you define the name of the field and the data type. Okay? So for example, name and data type in this case is text. We'll click OK. And now we have a player name as one of our columns. What else might we save with our players? Let's see what you guys are coming up with. Level, class, health level, class. Yep, these are all good things. However, when you think about databases, you're going to start to think about how to separate this information, and you'll see as we go. If we're just talking about player, think about like the player account. For example, let's do email. All right, so we're going to do email. That was not what I wanted to do. We're going to do email. So we're going to create a new column called email. This is also going to be text, and we'll just click OK. So we have name, we have email. Now what else might we want? Let's do, how about region? Are they in North America? Are they on Antarctica? Where are they? Reason being is, depending on the region, we may change what server they're connecting to, for example. So let's add a region. So I'm going to insert a field here for a region, not Trihon. We're going to do a region. This is also going to be text. And we're going to click OK. And then we're going to do one more. Let's do, for the purpose of this demo, we're going to create a new column. And this is going to be the display name. So our player may not want their name out in the wild. So let's just give them the option to have a name, an email, a region, and a display name. All right. Now, when we enter all this information into this particular tool for creating a table, this table is not actually saved yet. We've just set it up, but we haven't actually saved it. When I click save, I want you to watch what happens. You'll notice it comes up with this crazy string. This is the language of databases. This language is called SQL. And that's why these databases are called SQL databases, because they use this SQL language for doing things. And in this particular case, fortunately, it's pretty human readable. This is going to do a thing called create a table with name, text, email, region, and display name. Okay? Now, I'm not going to quite do this yet because there's one other thing that I want to add to this table. And it's important when we're talking about relational databases. I want to add a special field called a primary key. The reason I want a primary key is because what happens if I have somebody with the same name and what happens if I have people with the same name? How do I know which one I'm getting? So if I need to find, for example, Rusty, and I have 10 Rusties, how do I know which Rusty? So now I have to look for Rusty plus the region, or Rusty plus the email, or Rusty plus the display name. It starts to get kind of crazy. So we're going to create a special field that is never shown to the user, and it is just the primary key. And I'm going to add this in, and I'm actually going to call this primary key, and we're going to call this player ID. Now, and we'll go ahead and keep this as an integer. It cannot be null. It has to have a value, and I'm going to set this to auto increment. And what that means is, in this particular case, it means that it is going to, for every player I add to the system, it is going to automatically add to that number. So 1, 2, 3, 4, 5, 6, 7. Okay? So now I'm going to save this table. When I do this, you'll see not null, primary key, auto increment, etc. So when we execute this, we should not get any errors. And we now have a table, our first table in our database. It does not have any data in it. If we look, you can see this is the data. There's nothing here. Okay, so let's add some data to it. All right, and I think I have, let me see if I have some pre-set, no, okay. So what we're going to do is we're going to add a couple rows to our data. So first thing, name. Let's go, who do we got in the chats today? Let's do Rusty, for example. Email Rusty at askadev.com. Region, let's go North America for Rusty. Are you cool with that? Display name, let's do Rusty. And we don't mess with the player ID. We just click save. Now you'll notice that when I do that, it automatically gave Rusty a player ID of 1. That is the primary key for Rusty. Okay, but let's add a couple other people here. Let's do Specta. We'll do Specta at unreal.com. And let's do, where do you want to be from, Specta? Asia, North America. And then our display name, let's use PBM. And let's do, where did you decide you wanted to be from today, Specta? Off the rails, welcome to the stream. Well, we're going to go with Europe for Specta today because there is a delay in the chat, so we'll do Europe. Let's add a couple more. All right, we'll do insert. This is going to be, let's do Warren, and we'll do Warren at warrenriggingguru.com, and let's do Antarctica, and we'll do W Warren for their handle. And then let's do one more because I want to show you one other thing about databases. Okay, let's do, who else we got in the chat today? Off the rails. So let's go name off the rails. And you can see I can type in here whatever, off the rails. And we're going off rail at unreal.com. And then let's make off the rails from North America because I want to show you something. And we'll go off the hook for the display name. Okay, so let's save all this. Now, our database is now made up of one table that has data in it. Okay, what is cool about this, about a database, is in its simplest form, like I said, it's just a bunch of tables, and we're going to get into how they're linked together. But what we can do, if I can remember where to do this here, SQL editor, new SQL script. Here we go. Okay, so we know we have a table and we know we have data in it. And this is where we start getting into the power of databases. If I want to find out all of my players, if I want to get all of my players, I am going to use the SQL language to query the database to give me all of that information. So this is going to be pretty basic because we only have one table. So what I'm going to do is I'm going to select star, which means everything from table player, and that's it. Okay? Very basic stuff. And when I run the query, it returns to me all of my users, all of our players. We got Rusty, Spectre, Off the Rails, and Warren. But here's the cool thing. With databases, what we can do is we can start to be creative or start to hone in on what we want. What if I only want players that are in North America? So what I can do with a database is I can say select everything from table player where region is equal to North America. Okay, and when I run this query now, you'll notice that all that comes back is only the players in North America. So if I wanted to do something with the data that only applied to North America, I can very quickly grab that information and make changes. Okay, so we have created a very simple database that has a single table in it. We've entered some data, and I've shown you a little bit about how we get the information back and why this becomes powerful. This is what databases are for. Now imagine the database for the player base for your favorite MMO game. It's massive. They need to be able to get that information fast. That's what databases do. They give you the information fast. Okay, so welcome to the stream, Lucky Dogs. And Milan, good to see you. Glorfendel, welcome from Syria. That's great. And Kartik, good to have you here. All right, so we have our tables, our one table, and if we look at our diagram, you'll see that our database right now is made up of a single table. Okay, now let's start to expand on this idea. All right, let's add a new table for if we're going to store our player save data. What are some other things we need to save out? You all chimed in with a bunch of them. A bunch of people mentioned positions and things like that. Before we get into positions, let's talk about items. Okay, so we're going to make a new table, and we're going to call this table items. All right, this is literally going to be a list of all the items that we can get in our game. All right, and in this case, let's create a new column. This is going to be a special column. This is going to be our primary key. This is our item ID. Remember, this is the one that makes an item unique, just in case we have duplicate names or whatever. It makes searching easier, and when we do get into the relationship part of this, it'll all click, hopefully, or you will all think we're trying to look at the matrix. But we'll go ahead and click OK. So we now have a primary key for item ID. Now, what things do we want for our items? Let's not belabor this. Let's just fire these out. We're going to go with item name. You all can chime in what you think I'm going to put in here. So we'll go item name, that's text. Let's do item type. I'm also going to make this text. And then let's do the effect. And this is going to be text, for example. And then let's do durability. How about that? Maybe the item durability. And that is going to be an integer. And then let's add one more. We're going to do the effect value. Effect value. And this will make sense as to why I'm doing this here in a second. Once we see the bigger picture. And I think integer is fine for now. But you could probably make this numeric or real if you wanted to. But for now, we can just do it with integers. Okay, so we've created all those fields. We're going to go ahead and save this. So when I save this table, once again, this tool's cool because it shows us the SQL language that it's using. It's very human readable. It's creating a table. These are all the fields. We've got our primary key, and we can go ahead and execute that. And now we have 2 tables in our database. And if we look at the diagram when we refresh it, you'll see we now have 2 tables. However, we don't have any items in our items table because when we look at our data, it's empty. So let's put some stuff in our items table. Now, we're going to do this. Cost, drop rate, those are all good. Rusty, those are great. And those are great examples of things that we will want to be able to do later. So this time when we enter the data, we're not going to cheat. We're not going to do it by using this tool. We're going to do it. Oh, I just messed up how did I do that? There we go. Nope, I just made it worse. Table items. There we go. Okay, we're not going to enter it by adding a new record here and clicking save. I'm going to show you what the SQL looks like to do this. So here's what we're going to do. We're going to write a SQL command. In this case, we're going to do insert. Let me make sure I've got my notes up here. We're going to go insert into table item. All right, and we're going to insert the item name. And this tool is great because it tells me that's one. We're going to do item type, and we're going to do the effect and the effect value, which is this one. Okay, and then the way this works is you tell it the values after that, and you give it the values. Why am I showing you this, y'all? I'm showing you this because when we go to do this in Unreal, we're going to somehow be accessing these SQL strings. So all the stuff we were doing last week to save the player information, their health, all those things, we're going to take that and we're going to be rewriting it into these SQL statements so that we can update our SQL database. So that's why I'm introducing you to this. So let's call this, we're going to do boots of speed, and we're going to do, it's an equipment. And then let's do, it is going to affect the speed, and the value is going to be 10, for example. And then at the end, if I typed all that right, if we play this, it will insert that into our table. If we go back to our table items and we click on refresh, let's see here. Insert into table. Did I run that command properly? Okay, table items, refresh. There we go. So we have our first item. Boots of speed, it's an equipment, it affects speed. Durability doesn't matter because it doesn't have a durability setting. It can be null, and the effect value is 10. So maybe the effect value will, based on the effect that it has, whether you're using a gameplay effect or whatever, this is going to look for the speed, and it is going to change our character's foot speed by a value of 10. And we could put in negative numbers, we can put in positive numbers, etc. So this right here, this insert statement, man, this my Wacom tablet is crazy sensitive today, so that's why it keeps rebuilding all of these things. So this insert statement is how database persistence and database engineers talk to a database to actually insert a new row. Okay, well, you can use a tool, but this is what the SQL language looks like. Now, we are going to cheat a little bit and we are going to populate our database with a bunch of SQL statements that I already have pre-made. So rather than forcing you all to watch me type this stuff out over and over and over again, you'll see here I've got boots of defense, I've got axes, I've got a whole bunch of things that are weapons, I've got some trinkets, some consumables, etc. So let's just see if this all works. If we run this, okay, and then when we go back to our items, if we refresh, we have a ton of items. Okay, now this is cool because you start to see some of the power of this. So we now have our items, and if we go to our search string, what we can do is we can do what we were doing before. We can select star from table items, and let's just say we only want consumables, right? Where where type. Hold on, what is the name of that field again, y'all? Item type, that's right, where item type. Item type equals weapon. So this is going to select all the weapons, and I can find out all of the weapons in the game. So if I run this, it returns all of the weapons. If I want all of the consumables, because I need to see, I just want a quick list of all the consumables in the game, I can kind of just run this, and you can see we have mana potions, health potions, gold, silver, copper, and Bitcoin. Sweet. And then these are the current effect values, right? Like if whatever you happen to use that for. So we now have two tables. We have our table player, and we have our table items. Now, how do we potentially give our player these items to work with? And the idea here is what we're going to do is we have this big list of items. We're going to create a new table. Let's call it player inventory. And the inventory is going to reference the items table. So let's do that. Before I do that, let me double check how we're doing in the chat if anybody has any questions. Okay. Yes, Lucky Dogs, I am going to show you what a join is. Is it possible to advisable to work on an Excel file, import later? Yes, you can do that, Rusty. However, so most database tools have the ability to import and export CV files or straight to spreadsheets. And in fact, even Unreal Engine has that for the data tables that it has in Unreal Engine. And when you're working with artists, non-engineer, non-database engineer people, a lot of times there is a table, for example, that the designers will update as opposed to actually updating the database, and or a web interface for updating the values for that way they don't have to know all of this stuff. Okay? But let's continue our journey. We now are going to start connecting our tables, and this is where the relationship part of a relational database comes from. So we're going to create a new table. This table we're going to call table inventory, and just like we did before, we're going to give it a primary key. This is going to be primary key. Do I want this to be, player table player inventory ID. Make sure I spelled that right. It's an integer, it's not null, it's auto increment. Click OK. It is worth noting that a lot of database engineers and stuff, they don't like using auto increment ints because there's only, depending on how many decimal places you're using, you can only get to 65,000, or depending on however many thousand. So there's a fancy identifier called a GUID, G-U-I-D, a global unique identifier, and it's a big crazy long list of strings. So, all right, what is our inventory? What's special about inventory? In this particular case, we're going to do something a little bit different in here. So our inventory, every entry in our player's inventory is going to have two things. We're going to have the player that it's associated with, and that is going to be the foreign key for the player ID. So we're not actually going to enter the player's name in this table. What we're going to do is we're going to enter their ID, their player ID here. All right. And so that's going to be one of our foreign keys. And then the other foreign key we're going to use is we're going to use our foreign key for the item ID. Okay. And those are both integers. Now, what this is going to do is it's actually going to reference our other tables. I'm going to show you how to do that in a second. Now, when we do this, we're going to also have in here, the quantity, for example, quantity. That's going to be an integer. And let's go ahead and have in here also is equipped, for example. Okay. So we now have this table. We'll go ahead and save it, and we'll go ahead and execute to add it. And now we have a player inventory. Now, how does our player inventory work? So what we're going to do is, I think I need 5 players for my stuff to work. I only have 4. I need one more player. Who am I going to voluntold? Bart. Welcome to the game, Bart. So we're going to add you in here. Oh, goodness. We don't need that many. Let's just go. It's going to be Bart. Bart@gmail.com. And they're going to be from Asia. Thanks for moving to Asia, Bart. We're going to go Bart in for display name, and the player ID is going to be what it is. So let's just see, can we save this? Yeah. Oh, but we got a whole bunch of null players too. So let's get a few more volunteers. Lucky Dog @gmail.com. Let's do Australia. I probably spelled that wrong because Australia. Okay. And then let's do Lucky. Not Lucy. Lucky. Okay. And I think we can just delete these two if it'll let me. Okay, and save. All right, cool. So we have more players. The reason I need that is because I'm trying to save us time, so you all aren't sitting here watching me do this. So here's what we're gonna do. Let me type out the first one so you can see what we're doing here. What we're going to do is we're going to insert into table player inventory. We're going to insert a bunch of stuff. Okay, we need our FK player ID, or let's do FK item ID. Our FK player ID and a quantity, and an is equipped. Okay, and then we're going to give it values, and let's do 3111. And you're like, what the heck does that even mean? And also, why does that seem like that is spelled wrong? Table inventory. Oh, because I didn't call it. I called it inventory. Okay, I should have called that player inventory, but we should be good. Actually, I'm going to show you how to fix that. So if we go back to our script, so this insert is going to insert a record into our inventory. If we look at our inventory data, you'll see we have one record. It's just a bunch of numbers. That doesn't super help us. We know that some foreign key player ID of 1 has an item with an ID of 3, and they have one of them, and it is equipped. But this isn't very human readable for us. All right, so I'm going to show you how the database world makes this make sense. But before we do that, I'm going to rename our inventory, if I can. Rename to table player inventory. And we'll go with OK. And that's updated. Great. And then what we're going to do is we're going to populate a bunch more of these. Okay. So let's put in a bunch more of these. I not call it table player? Table player inventory. Did I not save that? I did not save it. Save it. Execute. All right, now it's actually saved. Now we should be able to execute this. Oh God, that mouse thing. All right, cool. So let's move this back over. Okay, so if we look at our table player inventory and we look at our data in this, you'll see if I refresh this, we have a bunch of numbers. These don't super help us. If I was going to tell you, hey, as a artist or a designer, knowing that this FK item ID is 1 and 3 and having to look this up, that's not very user friendly. But databases are built for this. Okay, so what I can do is I can do a select star from table player inventory. All right, and what we can do is we can tell the database that to take those foreign keys, the item ID and the player ID, and rather than giving me those numbers, to go to those tables and give me all the information from those tables. So what we're going to do is we're going to do what's called a join. I'm going to left join, in this case, table items on FK item ID is equal to primary key item ID. And then I'm also going to left join table player on FK player ID equals table player dot PKID. Okay? So what this is going to do is it's the same select as before, give me everything from the inventory table. But what these joins say is, and there's like all kinds of different joins, you all like there's left joins, there's right joins, there's inner joins, there's outer joins, depending on what you want to do. But the point is, when we run this, what happens is it goes and it gets all the information from the inventory table. You can see it here. We have our player ID, our foreign key for player ID, and our foreign key for item ID. And then the quantity, whether it's equipped or not, and then the primary key for the item ID. But you'll notice that the other thing that it does is it also goes and grabs all of the item information and the player information. All right? And if I wanted to clean this up, rather than picking everything, what I could do is I could do, let's get quantity. Let's do table player inventory dot quantity, comma, table player inventory. Did I ever tell you all that doing these things live is fun? Is equipped. And then let's get table items dot star, comma, table player dot star. Now what this is going to do is this is going to get rid of all the gobbledygook at the beginning, like these player inventory IDs and everything like that. And instead, it's just going to get me the quantity, whether it's equipped. I don't need this PK item ID, but that's coming from the table item. So you can quickly see, now I can see which item IDs, etc., each of these players have. Now, if I wanted to, I could also specify I only want the items that Off the Rail has. Okay, and to do that, so Off the Rails player ID is 3. Okay, so what I can do up here at the end is I can say where table player inventory dot FK player ID for the foreign key player ID is equal to 3. So when we do this, this should only give us Off the Rails stuff. Okay, so we now have, this is it. It's all starting to come together, y'all. All right, we now have 3 tables. We have our player, we have our items, and we have our inventory. And what we have in our table player inventory is we have all of our players and all of their inventory as a running list. And if I want to get the items that Off the Rail has, all I do is I tell the table, the database, to give me everything that's in the player inventory table that has a foreign key that matches Off the Rails player ID. And what I get back is I get back all the items that Off the Rails currently has. Is everybody with me so far? Okay. So now, if we take a look at our database view, oh man, once again, I got to get a new locking tablet, y'all. If we refresh this, we actually have 3 tables. But what, Bart's like, nope, I'm not with you. Okay, hopefully, Bart, you at least understand that a database is a bunch of tables with data in it. All right? Okay, cool. So what we have is we have our player data, we have our inventory data, and we have our items. But we haven't actually defined any relationships yet. So let's talk a little bit about how we define the relationships. Right now we're using loose definitions. There is no specific connection, but we can make one. So here's what we're going to do. In our table player inventory, what we're going to do is we are going to, underneath the properties, we're going to set up what's called the foreign key. Now, we named our foreign key already as fk underscore, but what we're going to do is we're going to formalize that. So we're going to insert the column that we're going to use as our foreign key is our foreign key for the item, and it's going to reference in the items table the primary key for the item ID. Okay, all this does is it formalizes that connection. Okay, and we loosely understood it just because we used good naming, foreign key, primary key, etc. And we're going to add one more. We're going to add one for the foreign key for the player, and it's in the table player primary key, etc. We'll go ahead and click OK. And then let's save this. And I want to show you what happens. First off, the SQL gets nuts, just so you know, because I spent a lot of time trying to forget all this. I don't know all this. Thank goodness for GUIs, because this is awesome. When we execute this, what I want to show you is when we go back to our database, you'll notice that now, what did I do? Okay, now we have connections. Okay, these connections visually show us how these tables are related to each other. And that is why this is called a relational database. So, JB, welcome to the stream. All right, so if we click on any of these, it will tell us, it'll show us, it'll highlight us. So the table for player inventory, all of the entries in there, they have a connection on FK, the foreign key for the item ID, to the table items associated entry for that item ID. Same thing for the player. This is where the relationship comes from. Now, why do we do this? We do this because it makes finding stuff super fast. Okay, but 2, imagine that you had a player, you had all of their inventory, all of their game saves, everything all set up, and they left the game. They decided to go play something else. They deleted their account. You released a new thing and they rage quit. Whatever it is, they want to delete their account or they make a new one. Okay? When they delete their account from table player, what you can do is you can set these relationships up so that if the player gets deleted, it will automatically go to the inventory. It will find everything associated with that player and it will delete the inventory, and it will also remove the references. Okay, so what it is it's a way for you to make changes whereby you don't have to go to each of the individual tables to make the change. Simply updating it will go ahead and have the cascading effect. And so by building out these relationships, it makes editing and maintenance a whole lot easier. Some people in the database world argue that sometimes it makes it more difficult, but because now you are absolutely required to have a foreign key for your player ID, and if you don't, it doesn't know what to do with it, as an example. All right, so we have a very simple database for our player and the inventory they have, but we haven't really talked about the save games. So let's see if we can break y'all's brain and get back to some of the things that you were talking about before. We are going to make tables for our save game, but we're going to split it into two. Okay, so the first table we're going to make is going to be, let's go ahead and right click on this. We're going to create a new table, and this table is going to be called table save slot. All right, and the save slot is going to have an entry. Ooh, what is that? No, I'm in the wrong thing. Here we go, columns. Here we go. We need a column. This is going to be our primary key. Hold on, I just spaced save slot ID. It's an integer. It can't be null because we need it, and it's going to auto increment. All right, we'll go ahead and click OK. And then we're going to add a couple other fields. You all already rattled off a bunch of these. So let's just go ahead and do this. So let's take our position X, for example. We'll keep that as an integer. We're going to add in, these are all the things that you all were calling out before. Position Y, okay. And depending on the type of database it is, you could use different data types, so you don't have to separate these out. But in this particular case, the way this database works is it doesn't understand vectors. And then what I want to do is I want to actually add a couple things in here like log date, and this one we're going to make as text. A lot of databases have a date time format field, so you can actually use a date time instead of text, but that's okay. And then the other one that we need is we need our player ID. So we need a foreign key for our player ID here. And the reason being is I want to, I feel like we need a name. Yeah, we do. We need a name too. Hold on, we need a slot name, y'all. All right, so imagine your player goes to save a game. Just like when they bring up that menu, there's a slot name. When they save that slot, in addition to their position, which player it is, etc., we're going to save all that information. This is how all this gets set up. We go ahead and click on save, make sure that our primary key is our save slot ID, and we'll go ahead and execute that. Okay, so now we have a new table. And if we look at our database and we refresh it, we have this new save slot. It is currently not associated with our player yet. So if we go back to our save slot, we can set up our foreign key. And so if we insert this, we're going to take our foreign key for our player ID. It's an integer we're going to associate with that. We'll go ahead and do that. We'll save that. We'll execute that. And then we'll go back to our save slot. And now you'll see we have our save slot. However, wouldn't it be cool if when we save a slot, we also save all of their inventory so that they can go back to different sets of inventory in time? So we're going to create one more table. All right. And we're going to create a table called slot detail. You all are amazing for hanging with me in this because this is a fun, I never thought I would be trying to go over this. So this is going to be slot item detail. Okay. Now, what we need to do with this one is something a little bit, hopefully you're kind of thinking ahead a little bit here. We definitely need our primary key for save slot item detail ID. This is, once again, this is our primary key, so it's not null, it's going to increment itself. Then we're going to insert a couple things here. Okay, all this slot detail is going to be is for each slot that our player saves, there's going to be a separate list of all the items that were saved with that slot. So when they pick that slot, we can re-equip those things instead. All right, so in order to do that, we need to know which slot that this save slot detail is associated with. So we're going to give it a foreign key for our save slot ID. That tells us the slot. So whether it be slot 1, 2, or people, it depends on how their users name things. This is going to be an integer. Then we need a couple other things. What else do we need? We need to know what items are in there. So just like our current inventory, we want to track our inventory per slot. So let's get our FK inventory, our FK item ID. Okay, and we'll go ahead and put that in there. And then let's do, we're going to need our quantity, for example. So let's get our quantity back in there. quantity, I spelled that right. And then we're going to do is equipped again. So this is going to be a slight, kind of a per slot shadow version of our player's inventory. It's a snapshot of their inventory in time when they save the game. All right, so let's save all of this. And rather than, because we are running out of time, rather than going through all of the fun of showing you how you have to look this up by figuring out which slot IDs, etc., we're going to skip. But before we do that, we're going to go ahead and set up our foreign keys. So let's insert. For this, we don't need our player in this case because our player is saved in the slot. So with our slot, what we're going to do is we're going to use FK slot ID. It's going to use the primary slot ID. That's cool. And then we need one more. We need for our items, we need our item ID and primary key item ID. Let's save this and execute that. Now, when we look at our database, when we refresh this, we now have a little bit more complicated of a design, but the thing is we can visually see what's happening. Our player has save slots. Right now, there's nothing that limits how many save slots they have. Those slots track the player's position, when the slot was saved, and a slot name, for example. And a save slot also has item detail. The item detail is a list of all the items and how many they had, whether or not it's equipped at that specific time. So what does this look like? Let's do some inserting in a SQL statement. So what we're going to do is I'm going to insert slot item detail, a bunch of stuff, so that we can populate this table without too much work. Okay, and if we go to our save slot, oh, but I didn't create the slots, did I? Okay, we do have a slight problem. If we look at our data, you'll see that we have all these numbers, which are super hard for us to read, but our slot IDs, we don't actually have anything in our save slots right now. We have no data in save slots. We need data here. So I did not pre-do that. So how many slots do we need? Let's do FK slot ID. We need 5 of them. So let's create those real quick. Oh, did it again. All right, so what we're going to do is we're going to insert and we're going to go, let's just throw these in real quick. Log date. I'm not even going to enter the log date. Let's do 1 for Rusty and slot name. Let's call this pre-checkpoint, for example. Okay. And then we'll go ahead and insert, and let's do 1 for PBM, and then let's do post checkpoint, and then let's do another one for Rusty. The order does not matter because the database is going to do this. Boss finale, for example, whatever you want to name your checkpoints. Bart is going to get a checkpoint as well. Save slot. This is going to be my favorite loadout. Sure. And then we need one more. And oh my goodness, let's just go off the hook. Warren. Let's get another one on PBM and one more on Lucky. And let's just go load out. Test. First day. Aced it. Cool. All right, and let's save all this. Okay, so now we have slots. All right, so what does this look like? Even though we don't have positions and all that, that's fine. You can use your imaginations. The final piece of this is, what does this look like when we select it? Because right now, if we look at this chart, the chart makes sense. These are our 4 tables. We hopefully understand that the slot uses the player, and a slot can also have item detail, and the item detail uses the items, and so does the player current inventory. right? The player current inventory, that gets updated as the game is running. Every time they pick up an item, whatever, this information gets updated, saved in the database, for example. Maybe the game quits when the player loads out. As long as you had repinged the database with that update, they would at least have the item that they found, as an example, okay? But if we go in here and we type select star from table saves, table save slot, and we look at this, this is pretty not select. I didn't spell select right. Hold on. This is pretty not helpful. Select star from. This is not helpful, right? We have pre-checkpoints, boss finales, loadouts, and tests, but we don't know who it's for. All right. So once again, we can use our database SQL language, and rather than selecting this information, what we can do is we can select everything from slot item detail, and we can do left joins on the save slots and the items and the players. And by doing so, now what we get is we get who each of these particular slots are associated with. So for example, what we could do is we could kind of cull this down, but the overall point here is now, let's see here. We know that this pre-checkpoint, for example, let's just do this. Let's do this. Let's say we know that Rusty, let's say we want to see all of Rusty's slots, okay? So let's just clean this up and let's just go where fk player ID equals Rusty is 1. Okay, when we run this, this is going to return to us all of Rusty's items for each of the different checkpoints. So at the pre-checkpoint, Rusty had 2 items, Boots of Stealth and the sword. And at the boss finale, there was a health potion and a Boots of Stealth, but also a pre-checkpoint also had Boots of Speed. So Rusty had 2 sets of boots at the pre-checkpoint. Okay, so in order to kind of put a pin on all of this stuff, basically what we have, all the database is a bunch of tables and data in the tables. Depending on the type of database we have, okay, you may or may not have a relationship. In this case, we built a relational database so that we can do things like grab the information from the items table. And the cool thing about this is, let's say that you wanted to rename an item or change the description. Like, let's say all of your items had descriptions and you realized that the Boots of Speed description had a spelling mistake. Rather than going around to every single item and updating it, what you can do is you can just update the item in the table items table and everything else will automatically get it. That's kind of one of the beauties of the database. Now, there are a couple other things worth mentioning about a database. So we use the databases because in general, we want to order our data, okay? We also mean with databases, we can grab lots of data, large amounts of data fast. So when you think about it, you know, companies like Facebook, your bank, stock markets, they're all running on databases. And those things come back wicked fast. So databases are engineered to be fast. Now, there's some trickery to it. You need to set up your tables properly so that you're not querying everything all the time. So there's an art to database and persistence engineering, which is why these individuals are amazing and the way their brain works is amazing. The other thing that is worth mentioning is the location of your database matters. So we talked a little bit in the beginning about if you have a switch, for example, you can use this particular type of database I was working with today is a SQLite database, SQLite 3. It is literally a file on your hard drive. or on the Switch or whatever platform you're building for. So it's really good for local setups, games that don't have to connect to the internet, etc. However, it does mean that your database is local and potentially hackable. So if you are making a competitive game, you generally don't want your database stored local, or if you do store it local, you have got to make sure that it is set up in a way where you don't deal with tampering, which gets us to remote databases. So whether or not you store it in the cloud, your own servers, etc., this is where the server authoritative games accessing the databases is kind of where it's at from a competitive standpoint, because it makes it a whole lot more difficult to tamper with progression, stats, and all those kinds of things. It's also worth mentioning that, and maybe as we get into this, you'll see we're probably, if I can get it set up for us to do a demo of how to connect to a database from within Unreal Engine, one of the things that you have to do when you connect to the database is you have to give it your credentials. You do not want to store your credentials on a player's machine, because if you give them the credentials, not all players will do this, but some players will take advantage of that, and they could start monkeying around with everybody else's account or their own account and giving themselves all kinds of crazy power. So generally, you have to make sure, if you're new to this, don't make the classic mistake of sending your credentials across the web or storing it locally. That's why all this stuff is done on the server, because it makes it a lot harder for tampering, etc., etc. So let me try to catch up if we had any questions for today. All right, let's see. I'm glad it's helpful for you, Rusty. That's great to hear. Milan, I don't actually know. Desidev, welcome to the stream. I don't actually know what the size on disk is, if that's what you're talking about. It is definitely the less glamorous part, but it is, if you think about it, like we've used a small example today. We were talking about player inventory, but imagine all the stats that you track for your players. Things like how often they're completing dungeons. The telemetry is often what it's called. So how many players are using this is where databases come in. Of your players, when they're running through the dungeon or your game or whatever they're doing, how many of them are running through it with the longbow versus the sword versus the two-handed sword? You can't really answer that without the data, but databases can help you do that. Not only that, you can start to look at things like win rates. So if everybody runs through the dungeon with a two-handed sword always wins, you may have a balancing problem. All of this stuff has to get stored and tracked somewhere, and your persistence and database engineers and how you do this is a huge part of that. And it gives you, it's not just about saving inventory, y'all. It's also about giving you information to provide better experiences for your players. So this world is big, it's awesome, and once you start seeing things like even things like what's the fastest completion time on a dungeon, maybe you realize very quickly that new character that you just released has a balancing problem. But yes, Warren's right. You can use SQLite to get a quick idea on size. I would have to do some research. I'll try to do some research to see if I can come up with some ballparks on rough database sizes. But here's the problem. You're not going to know, even if they tell you that the database for WoW is, however many gigabytes or terabytes, you don't know how much of that is a result of the storage of the player information, versus like how many players they have versus how many iterations in inventory or the status of the game or anything like that. But generally speaking, just to put it in perspective, the database that we created today so far is 28 kilobytes. And I imagine a lot of that is just the overhead of the table construction and stuff like that. We would have to do a lot of work to kind of fill it out. But that might be an internet search. All right, y'all. Something a little bit different today. Hopefully the walkthrough of relational databases gives you an idea of what you're getting into when you start talking about kind of like the next level beyond game saves and JSON files. I am hoping that next week, and we are going to cheat. I'm going to try to figure out which plugin we're going to use to do this. What we're going to do is we're going to take the next step, and we are going to try to use Unreal to connect to this database that we created today. I thought it was important for you to understand what was there from a background standpoint and appreciation of what your database and persistent engineers are doing in general. As always, y'all are troopers. This was, like I said, this was not as glamorous as a stream. So all of y'all who hung out and stuck it out, and anybody who's watching after the fact, thanks for checking it out. I hope it was helpful. I hope it was enlightening. And as always, thanks for being the best part of this adventure. Again, I probably wouldn't be explaining these things if it wasn't for y'all's questions. I hope everybody has an amazing rest of your day, awesome weekend, rest of your week, and I will catch you all on the next one. Keep an eye on the calendar. It's really important. Next week, I actually have some other commitments going on. I may have to shift it to Tuesday or Wednesday or something like that. Take it easy.